So this is our very first topic of the semester. What is Kbp and Mas? I'm going to go over this handout with you guys kind of quickly, but I do want you guys to take the time and really read it and understand it and digest it. You're going to have to look at this handout numerous times, read it several times, remind yourself of it several times. But the information in here really is key to beginning your understanding of what we're going to be doing in diagnostic imaging this semester. So you'll notice on this handout, I'm going to be using a lot of baseball analogies. Stick with me on it because it really does seem to be a concept that's been able to sort of help it stick for people. So first one we're going to talk about is what is KVP. So I show you a couple pictures here. We have a major league pitcher and a little league pitcher. They're both throwing baseballs, but obviously the major league pitcher is going to be throwing his baseballs with a lot more force than what the little league pitcher is. And when we're using x-rays, we're going to be using the same type concept. We're going to be having to decide how much force we want the x-rays to come out of our machine with. It's going to be a key point to every x-ray you take. Did you use the right amount of force? So if you just kind of let it stay at the common sense point, things that are high force are going to have a lot of penetration power. Things that are low force, not going to have a lot of penetration power. So if we were x-raying something that's really big and really thick, think, let's just use cats and dogs to keep it a little bit simple, but a dog thorax versus a cat leg. We're going to need a lot more force to get through something like the dog thorax than we are the cat leg. And if you don't use the right force, you either don't have enough penetration power or you completely burn through it. So we have to choose. If I'm x-raying a dog thorax, I probably want the major league pitcher throwing my baseballs. High force x-rays. If I'm x-raying a cat leg, I probably want the little league pitcher throwing baseballs. Low force, because it's a thinner object. So big takeaways you guys want to remember right here, right there. Commit those to your memory. High force, high KVP, high penetration power. Low force, low KVP, low penetration power. Get those in your mind. Write them down on a little note card. Keep them with you. That's going to be the first key that we're going to use when we come to analyzing x-rays. Now, the next thing that you guys need to understand is that when x-rays hit the film, they turn it black. Now, if you've done photography work, this might mess with your brain a little bit because it's opposite. But the main key, this is the next key you need to remember. When x-rays hit the film, they turn the film black. So you need enough force to penetrate through your different objects, but not too much. So if we look down at sort of these next 4 x-rays that I have here for you guys, you can see this one right here. That's very, very black. A lot of x-rays hit that film. They burned through it. So much force went through it that you can't even see what you were trying to look at. You used way too much force. So this Major League Baseball player threw the baseballs way too fast. You need to back off that force a little bit. And if we look down here at the bottom one, that's a pretty white looking image. Those x-rays didn't get thrown out with quite enough force. We need more force to penetrate fully through the object. So this is what force is going to do for us. We want the right degree of blackness on our film. We don't want it to be completely burned through, and we don't want it to be completely light. So if we look at the little question I have here for you, we have a cat limb that measures 2 centimeters, a 12 centimeter, and an 8 centimeter. So something that's 2 centimeters, that's going to be our thinnest. These are our different KVPs. 44 is going to be our lowest KVP. So that's going to work really well for something that measures 2 centimeters. Then I'm going to look and say, okay, well, here's my highest KVP. That's going to work best for my biggest centimeter. And then 8 centimeters, something in the middle of the 56 KVP is going to be good. How exactly you get these numbers, we're going to talk about that in just a few minutes and have another video for you guys on how exactly we figure out what those numbers are. But for right now, I want you to understand main concepts. X-ray hits the film, it turns the film black. High force X-rays have high KVPs and a lot of penetration power. Low force X-rays have low KVPs and low penetration powers. We need to use the right force so that we can see the objects that we're x-raying, but we don't burn entirely through them. All right, so moving on to the next thing that we're going to be adjusting when it comes to getting the right quality x-ray to come out of our x-ray tube. First, we just talked about KVP, number KVP related to the force that the x-rays were coming out with. Now we're going to get to adjust a couple more things. We're going to get to adjust something called MA, which stands for milliamperage, and we're going to get to adjust time. These are going to relate to how many x-rays we allow to come out of the x-ray tube and how long we allow it to happen for. So you're literally going to have one dial that you get to adjust the force, the KVP on, and you're going to have another dial that you get to adjust how many x-rays come out, and you're going to have a third dial where you get to adjust how long do I want those x-rays to come out with. So MA relates to number, time relates to how long. And these two factor together into something called MAS, milliamperage per second. So if you take your MA, the number of x-rays, and you multiply it by how long you're allowing to come out for, that's always going to give you your MAS. So this is your next important equation to remember. MA times time equals MAS. So commit that one to your memory, write that one down on your little note card, keep track of that equation because you will be using it all the time in this semester. So MA, number. I just have a couple images for you here. We can either send out a couple of x-rays from the machine or we can send out a lot of x-rays. And this is going to affect how our x-ray looks on the film. Remember, films look black when x-rays hit them. So if I throw out, say, one x-ray at a film, it's not going to look very dark. I didn't really hit it with much radiation. If I throw out 3 or 100 x-ray beams at it, a lot more x-rays are going to hit it and my film's going to look a lot darker. Now I'm not going to be able to affect force. It doesn't matter if I have that big dog thorax and I have a little league pitcher throwing baseballs at it. It doesn't matter much if he throws 1 or 10 or 100 baseballs at my dog thorax. He's not really going to get through it. He's not going to change the force. There's just going to be more radiation hitting it. So where this comes in is when you choose the right force. Remember I said force is really key. So you have your dog thorax, you say, okay, I need more KVP. This is a major league pitcher situation. So you choose the correct force, and then you have to sort of fine tune it and say, how many of these x-rays at that force do I want to hit the x-ray film? If you choose a low number, your x-ray is going to look pretty white. If you choose a higher number, the more x-rays that you take, the more x-rays that are going to hit the film, and the darker your film is going to look. I kind of think about this as a bruise, right? If you get hit with one high force baseball, it's going to hurt. You're going to have a little bit of a bruise, but if you keep getting hit by more and more of them, your bruise is going to get darker and darker. So MA is just number, how many x-rays are hitting the film. It's going to affect density, how dark does the film look. Time is going to just be how long you allow it to happen for. So you can sort of adjust your number by how long you allow it to happen for. If you allow sort of one x-ray to come out for 10 seconds, that's going to be a lot of exposure. If you allow one x-ray to only come out for 1/10 of a second, not much exposure. So you can adjust your MAS by adjusting either MA or time. And we'll be making MAS charts and diving really a lot deeper into this concept in the rest of this week and into next week. But that's sort of your basic understanding and concept for it. So when we talked about KVP, we talked about force. Here we're talking about number. One thing that I like to think of with MAS is it makes your blacks blacker. It doesn't really affect, like I said, if the x-ray is going to go penetrate through or not. But if you have the good force and you need to figure out how black you need your x-ray to look, that's where you're going to be adjusting MAS. It's going to make your blacks blacker. So here's another set of x-rays that we're looking at, figuring out what our MASs look like. So MAS makes our blacks blacker. This one here is our lightest looking x-ray. It's going to have our lowest MAS. And then we kind of look through. A is going to be in our middle, And if we look over here to C, it's definitely the blackest. The blacks are the blackest. That's going to be relating to our higher MAS. So note, on the first ones that we looked at, we really saw a difference with the penetration power. We saw x-rays that were like really white all the way up to ones that were completely black. This one, you're not seeing that drastic of a change, but you're definitely seeing your blacks get blacker as you go through it. And again, there's going to be an ideal force, and there's going to be an ideal MAS that we're taking our x-rays with. And we get to spend the next 16 weeks learning how to do that. And guys, it's super exciting. It really is. These are your basics. As long as you kind of remember some of the very basics that I'm giving you here, you just apply that knowledge for the next 16 weeks and we're going to rock it. It's going to be a lot of fun. So my next part I have for you guys is how we produce that quality image. I'll let you guys read through that. I've talked a lot about what I've already written there in this last 10 minutes you guys have been listening to me talk for. And this is also where I introduce Sante's rule for you. I have a whole nother video that you guys can click on where I go through Sante's rule and I really break it down for you guys. So I'm going to kind of skip over that one for this video as well. And then there's this grid factor thing I talk about. So grid factors is something that we're going to use if an object measures over 10 centimeters. We are going to talk a lot about grids in a handful of weeks, in about 6 weeks or so. We're going to dive really deep into grids. For now, I just need you to know that a grid exists. There's a grid factor. You're told what the grid factor is by your manufacturer. At MATC, it's 8. So you'll understand it a little bit more. We'll talk about it a little bit in lab. And I just kind of leave you hanging, and we'll get back to it in a few weeks. So this page here for you guys is going to go through, again, more of what I just talked about and a lot of words and writing for you guys to go back and think about it and really digest this information over the next few weeks. Last page of my handout here talks about some technique charts we're going to be developing. We are going to be developing those in Lab 2. We're starting to talk about them already this week in Lab 1. And you're going to have some assignments this week on Blackboard where you're going to be talking about these technique charts and starting to dive into how we actually create these and what they actually are. But this is where we're going to be using our knowledge of MAS and KVP and applying them to the actual animals that we're going to be radiographing, that you guys will be radiographing for the rest of your careers. And then the nuts and bolts here, guys, I kind of broke it down for you what you really need to remember, that KVP is force. The thicker the object, the higher your KVP is going to need to be. It's going to affect contrast, how black and white the image is. So remember when we looked at those x-rays, things were either white or they were black. Big changes are happening when we're looking at KVP. Contrast is a word you're going to want to associate with KVP. MA, we talked about the number of x-rays being released, time, how long you allow them to be released for. MAS is that MA times time. And it's going to be telling you the total number of x-rays that hit the film. And it's going to be affecting density, how overall dark the image is. Your blacks are going to be blacker. Or if it's too black, you can make your whites whiter by backing off on your MAS. So I know this is a lot to take in. Go back, re-listen to the video as you guys need to, reread through this document. And we will be diving in even farther to MAS and KVP, and you guys are well on your way. I'm excited to be on the travels with you.